All right, so let's look at contact forces. A force of magnitude 7.50 newtons pushes 3 boxes. Box 1 has a mass of 1.30 kilograms, box 2 has a mass of 3.20 kilograms, and box 3 has a mass of 4.90 kilograms. Let's calculate the contact force between boxes 1 and 2, and then between 2 and 3. Don't forget what we learned about Newton's second law, force equals mass times acceleration. Looks like a 9. Let me fix that. There we go. Now we know what it is. And this equation here, this can be rewritten as acceleration equals force divided by mass. So all of these 3 boxes are moving as a system. They all have the same acceleration. So let's figure out what that is. So the acceleration of each box, which is the same, whoops, pay attention, is the force divided by the mass of the entire system. So all 3 boxes together. Okay, so let's see what that is. So, calculator. Most of my calculators should hopefully show up on the screen. All right, so the force divided by the total mass, 2 and 9. And we get 0.7978. They've given us 3 significant figures for each of these values. Normally during calculations, I'd keep 1 extra, but this is acceleration, so it's cool. Let's keep that at 3 significant figures as well. So 0.798 is what we get, meters per second squared. And I gotta work on my handwriting. All right, so that is the acceleration for each box. So now let's figure out what the contact force is between boxes 1 and 2. So these 2 right here. So we're moving this direction. That's what the original force is. And so here, the force only needs to be strong enough to move 1.30 kilograms. And since we know force equals mass times acceleration, we've got the 1.30 kilograms times that acceleration we just found, 798. So the force needed to move box 1, or the contact force between boxes 1 and 2, is going to be 1.3 times 0.798, which is, well, let's see, at three significant figures, it is 1.04 newtons. So that is the contact force between boxes 1 and 2. Let's do the same idea for the force between boxes 2 and 3. 2 and 3. Now this time, we need to be able to move boxes 1 and 2 from this. So we have more mass, so it's going to take a greater force because the acceleration is still the same. So we need to move box 1 and box 2. The acceleration is still the same. So let's see. Oops, open up. There you are. So if we take box 1 plus box 2, let's multiply that by the acceleration, 0.798. The force required, or the contact force, we're going to get 3.59. So there you have it. Those are the contact forces between boxes 1 and 2, and then between boxes 2 and 3.